In our last lesson, we were working on converting between the three different forms of the quadratic. Today, we're going to look at a process called completing the square, which is used to change a standard form equation directly into the vertex form without having to go to the factored form first. Our first question here is a warm-up question to determine the vertex of each of these quadratics, these parabolas. So take a moment, put the video on pause, and try to figure these questions out. Okay, the first one has a vertex of, grab the right pencil here, of a 4 and 11, and that's because this is directly in vertex form. We also know that this parabola is opening down and it's narrower than our regular y equals x squared parabola's opening. All right, for the next one, it's standard form. To be able to write that in vertex form, what we know so far is that I would put this in its factored form and then get my midpoint of my two x-intercepts from the factored form to get the x-coordinate of the vertex, and then sub that in to get the y-coordinate of the vertex. I'm looking for two numbers that are going to add to 3 and multiply to negative 28, and I believe positive 7 and negative 4 will do that. Because this is a simple trinomial, that's just going to be an x plus 7 and an x take away 4. That tells us our two x-intercepts will be x equals negative 7 and x equals positive 4. So we're going to find the midpoint of those and then sub that into the equation to solve for the y. Okay, so I figured out that the vertex is going to be at negative 1.5 and negative 30.25 as the y-coordinate. All right. Moving to the last example here, I'd be looking for two numbers that are going to add to 2 and multiply to 10. And my two possible combinations are 1 and 10 and 2 and 5. But unfortunately, they add to 11 and 7 and not to the positive 2. So this one is a case where we can't use this factoring process to be able to come up with the vertex form. So we need an alternate possibility of, or an alternate way of doing that. So it says here we could also convert the standard form of a quadratic into its vertex form by completing the square. We're going to learn how to do that, but first let's talk about what a perfect square is. A perfect square is just a number that can be written with an exponent of 2, or an expression that can be written with an exponent of 2. For example, a perfect square could be the number 9. 9 is a perfect square because it can be written as 3 to the exponent of 2. The polynomial x squared plus 4x plus 4 is also a perfect square. When I factor that one, I can rewrite that as an x plus 2 all to the exponent of 2. So it is a perfect square. Now that's handy because you'll notice that this piece right here looks like part of our vertex form. If you look up at part A here, part of the vertex form of the quadratic. So that's the method that we want to use with this. At one point we had a homework question that had asked us to figure out what number would k be equal to be able to complete this square, to make this into a perfect square. So the question is, what can k be equal to make this into a perfect square? Well, we know that if I were factoring this as a perfect square, I would square root the first, I would square root the last and take the sign from the middle, and that middle number has to be twice the product of what's inside the bracket here. So if I have x times something, I'm going to need to figure out, or to work backwards, instead of doing twice the product, I'm going to take my 8 here and I'm going to work backwards. I'm going to cut that in half and get a 4. So I'm going to have this as a 4 here. So that gives me x plus 4. If I square the first, that gives me the x squared. If I squared the last, that would mean k would have to equal 16 because 4 squared is 16. And if I take the double the product, if I take x times 4, I get 4x. I double it, I get the 8x. So that was a process called completing the square, which we're going to use here. So let's convert this last one into its vertex form by completing the square. Here's our process. We're going to take, this is a straightforward one because the value of the a is just a 1, so we don't have to worry about the very first step when it's not a 1. There's a step that we have to do before this one. If I were to figure out what number I would need to complete this square, I'm just grouping these first two terms here. I'm going to take half of the 2, half of 2 is 1, and I'm going to square it. I'm going to add 1, but now I've changed my equation. I'm going to also subtract 1. The net result here is 0, and I'm going to keep my plus 10 on the end of that. So my two lines, my original equation and this one now, are exactly the same, but I have this extra plus 1 and a minus 1. The net result here is 0, but what I have left here and here are exactly the same as what I had originally. Now, if I group these 3 terms right here, that makes a perfect square. That's going to factor as a perfect square. Square root the first, that's going to give me an x. Square root the last, that gives me a 1. Take the sign from the middle, and that should be all to the exponent of 2. I'm just going to back that up a little bit. All to the exponent of 2. Now, that takes care of the part that I have here. What I still have on the outside is the extra minus 1 and the plus 10, which then I'm going to combine together. If I have negative 1 and I add 10, that's going to give me a plus 9. I have, in 3 lines, taken that standard form and changed it into its vertex form by completing the square. Now, we're going to do the same thing with part B. So part B was the equation. Let me see if I can squeeze that in here. I easily can squeeze that in here. So part B was the equation y equals x squared. This one's going to be a little trickier though. Plus 3x minus 28. Okay, I'm going to lump the first 2 together. That's going to be the start of my perfect square, and I have to figure out what the k value is. What would I add to the end of that so it will factor as a perfect square? We're going to work with decimals, and that's okay, because I'm going to take half. I'm going to take that 3x, I'm going to cut it in half. So 3 divided by 2 gives me 1.5, and then on my calculator I'm going to square 1.5, and that gives me a 2.25. 2.25. So I'm going to add that amount, but I can't just go adding an amount to an equation because then it's not the same anymore. I'm also going to subtract that amount. So the net result is 0, and I still have the minus 28 on the end of that. These 3 terms here will factor as a perfect square now. Square root the first, I'm going to square root the last and take the sign from the middle, all to the exponent of 2. And then I'm going to collect those like terms on the end. And that gives me a negative 30.25. Now I set up at the warm-up example B that the vertex was at negative 1.5, comma, negative 30.25. And there it is. In 3 lines we were able to come up with the vertex without having to do all of the work that we did up here for example B. All right, I have some more examples to do, but I'm going to move to the next slide for that one. Okay, so here are some examples. I've just crossed off B because we've already done 2 examples on the previous slide of this. I want you to try part A now that we've done the 2 examples. See if you can remember the steps there, and if not, that's okay. We're going to summarize the steps in a few minutes, but put the video on pause and try this out. Okay, so first 2 terms get lumped together. I'm going to take half of that middle term. Half of negative 6 is negative 3. I'm going to take that negative 3 and square it, and that gives me a 9. I'm going to add the 9 and subtract the 9 to that equation to work with it. So we're going to have y equals x squared minus 6x, and then we're going to have a plus 9 and a minus 9. We always put the plus first and then the minus, and I'm going to have to move that. Oops, eraser, not working for me for some reason. Oh, there we go. Yep, that's my inability to manage the technology in an efficient manner here. All right, and then we still have the -4 from the end of that. These first three lump together to factor as a perfect square. Square root the first, square root the last, take the sign from the middle, all to the exponent of 2, and then we're going to collect these two like terms here to get a -13 on the end of that. So in 2 steps, we have the vertex form. All right, when you get to part C here, which really should be part B because I crossed out the actual part B, we have the coefficient of x squared not being a 1 anymore. So we have an extra step to this. Our first step will be to common factor the a out of the first 2 terms. So we're always just dealing with the first 2 terms. The constant term just slides off to the side and we deal with it at the end. So I'm going to common factor the 2 out of these 2 first terms. So I divided both of them by 2. The +3 is just going to travel along for the ride here. And then I'm going to repeat my process up above with what's in the brackets here. I want to complete this square. I'm going to take half of 4, half of this term, the b term, half of 4 is 2, and square it, I get 4 again. So we're going to have still have our x squared minus 4x, but then we're going to add 4 and subtract 4. And then close our bracket, and the +3 trails along at the end. Now here's another extra step because this a value is not a 1. We need to kick the -4 out of the bracket. It doesn't complete the square. It doesn't belong with them. So to kick it out, we're just going to multiply the 2 with that very last term. So we're going to leave the 2 in the front. We're going to have still our x squared minus 4x plus 4. But we're going to multiply the 2 with the -4. We get -8 and a +3 still on the end. Now we're ready to factor that perfect square. Square root the first, square root the last, take the sign from the middle, all to the exponent of 2. -8 plus 3 will be -5. So this parabola has a vertex at 4, -5. All right, try the next one. See if you can remember those steps, modeling it after part B, and we'll summarize our steps here in a moment. Okay, common factor the a value, the -3, out of the first 2 terms. Oh, that's unfortunate. It turned into the same coefficient. The -3 times -4 gives us our +12. This completing the square is the same as the previous. We had an x squared minus 4x in the part B here. We know half of 4 is 2. 2 squared is 4. We're going to add 4, subtract 4. We still have our -5 on the end of that. We have -3. We're going to kick that -4 out of the bracket by multiplying that 3 with it. Sorry, the -3 with it. So a negative times a negative will be plus, and 3 times 4 is 12. We still have our -5 tailing along the end. Factor that perfect square. Square root the first, square root the last, take the sign from the middle. And I just realized I made a mistake on the other one. I hope you caught that mistake. I forgot to actually square root the last. Take the sign from the middle. 12 minus 5 is +7. So let me go back and fix. I made it, oops. Why, eraser tool, are you not working for me today? Ay, oy, oy. Let me try this one. There we go. I don't know why it keeps switching on me. I need Mitchell to tell me what I should be doing to fix that. Okay, so let me summarize the steps. Okay, we'll write those up here. Okay, so I've outlined the steps here. Remember, if the value of a is not a 1, that's your first step. Common factor the a out of the x squared and the x terms. And then you're going to divide the coefficient of the x term by 2 after you factored it out and square that answer. You're adding and subtracting that value. Then you multiply the subtracted value by the a value to move it outside of the bracket, and then factor the perfect square and combine the constants. So hopefully that makes sense for you. I believe there are examples in your textbook in this section 4.2 of your textbook if you need some extra help with that.